This is a follow-up video to the previous video on making a pie chart in Figma using generator. In the first video, I didn't finish the tutorial, but I didn't want to make it too long, so I split it into two. So there were three things that were not done in the last video. The first was the pie chart is not sorted. The second is that the thickness of the lines is not absolute. They do get thinner as the scaling goes down. And the third is that the width of the segments and the gaps are not equal, which they should be as in the tutorial. So let's first sort these. To sort them, we can come over here, move these nodes to the left, get a sort node, and then take the counts, which is what we want to sort, and run them through the sort node. There we go. So now they're sorted from the smallest to the largest. Except these are not the correct names because the list of languages is not sorted. So what we need to do now is apply the indices that came out of the sort node to reorder the words in this table. And the way we do that is we use a reorder node. So we will plug this in here, and we will plug this in here. And then we will run the indices from the sort to the indices of the reorder. There you go. Now the names are correct. Hindi is the largest represented language. So the next thing to do is to work with the thicknesses or the widths of these segments. But before I do that, I would like to reduce their counts because when there are fewer, it's easier to see the effects. The way I will do that is, this is where I apply the count. And so I'm going to insert a math node right here. Divide this by, let's say, 5, and then run the result of that into the repeat count. There we go. So this is now a reduced set of segments that we need to get looking correct, and then when we increase it back, we will know that it's correct as well. All right, so the first thing is these are getting scaled with the scaling of the ellipses or the segments themselves. That's because we're using scale node. Now, what we should do instead is we should delete the scale node and we should loop the segment directly, where the range output goes not into the scale width and height, but into the radii of the segment. So the width and the height get the same radius. Now, we're not scaling, but we're actually changing the size of the ellipse. That's because we're in center. Otherwise, it would look like this. But the X and the Y specify the center, so these are the radii. And now, if we set inner to absolute, it now uses pixels. So let's say we say 50. Now all the sections, of which there are some number, they all start at 50 because that's the absolute value. So now we need to start subtracting. So for each segment, we need to take this value, so it's outer radius, and subtract some thickness that we think is correct. So what's the correct thickness? Because we want each segment and each gap to have the same thickness, if we have, let's say, 3 segments, we need to have 2 gaps. That means we need to multiply the number of segments by 2 and then take 1 away because we don't need the last gap after the last segment. The way we do that is we take the number of gaps, which in this case we have reduced with this node. Let me highlight it in, let's say, magenta. This is the node. That gives us the number of segments that we have. We'll disable or remove it later. So now we need to take this, multiply it by 2, so Control-Alt gives me a new branch. Let's do this over here. So multiply by 2. And then I need to subtract generator still needs to be optimized quite a bit. I need to subtract 1. What do I do with this? Well, I need to take these, or this distance from the outer to the inner, which I calculate using a math node like this. I set it to subtract, and then I subtract from this. And so now that I have this distance, which I can adjust using these yellow nodes, I can now divide this. So I take a multi-math node, I set it to divide, and I divide it by this thing that we calculated to figure out the width of the segments. And now we plug this in here. That becomes the width of the segment. Now, before I can use it, what I need to do is I need to take the outer. So let me just get a math node. I'm going to subtract. I'm going to plug the outer in here. This will then go into the inner. For now, it's the same as the outer, so they're going to disappear now because it's going to be the same. And then this goes into this math node, which is where I subtract from the outer the thickness. And so you can see that now we have, it's still not correct, but now we have segments with the same thickness, at least. So another thing we need to fix is, if you notice that the segments start at this point. So here the last ones start at this point, but then they stick out different amounts. So what we need to do is we need to bring this point back in here by this much, so that when it gets spread by the range node, it'll get spread so that each one, regardless of the thickness or the width, will end up over here on this point. So the way we do that is we take this width that we calculated, and over here where we have 50 as the inner value, we need to replace this, or we need to add to it this thing that we calculated, which is the width of an individual segment. So we will take a math node. It's already set to add, so I'm going to run this through here and plug it back into the end parameter of range. And then I will subtract a width of a segment. So now you can see that they all end on the same point defined over here, regardless of the width of the segments and the number of the segments. So let's say they start at 30. There you go. They all start at the same inner radius. So I'll bring this back to 50. Actually, 30 is fine. Let's leave it at 30, because we're going to bring back the actual numbers, which are larger. So now the only thing left to do is to fix the actual widths, which are wrong. And the reason they're wrong is because here, this gives it away. So you see 3 segments, and then you see 3 segments as well, but they have different sizes. So what that indicates is that when I reduce their number, I got a fractional value. So what I need to do is to say round, which will then clamp it down to a whole number and give me something that is more correct. Except this is still a little bit wrong. And I think that's because I made a mistake. I'm supposed to subtract 1 and not divide by 1. And so if I now subtract 1 over here, it gives me exactly what I need. Now I can go up here, disable both of these, disable the division. This is going to take longer now because there are more segments to add. And there you go. I think the last thing that I will change is the gaps, which are changed. Where did I change this? Where did I set this? Oh, you know what? I think I named it. So I'm going to look for the node by starting with slash and then section gap. There you go. So here's my section gap, and I will set it to 0. Let me try 3. So, a little too thin. Let me try 0.5. That's a little better. So now the pie chart is complete as per the other example. If you want to try this yourself, you can either look at the tutorial built into Generator, or you can download this graph with this data set in the description to this video. Now, Generator is free software, but there is a subscription version. If you do find Generator useful in any way, please consider buying a subscription. Every subscription helps me pay the bills and keep making Generator better. In the future, I would like to also maybe hire some help, as Generator is getting to be quite big and it's getting harder to do just by myself. So again, the more paid subscribers I have, the quicker I get to that goal. Thank you for watching.